Okay, so hello friends. Finally, we will also try to put the performance measure in a one function. So let me take this Control X and let's go to Canon Utilities. Have one more function defined, accuracy cal, and what will be the inputs? We will decide that soon, and this will return the accuracy. Before that we have this one, so this thing should be, now this will come here. So so what we need are test labels, and these test labels are nothing but the ground truth, and this is the predicted labels, test prediction. Okay, so why this is giving undefined test prediction? Okay, so if it is saved, now it will calculate the accuracy and give, but still it hasn't. Okay, this one accuracy calculation, this return accuracy. Test labels are there, still it has not gone. ENBG test labels. Okay, test prediction. Okay, maybe this is indent problem. Okay, so it has gone now. So from this one we will calculate the test prediction classes are insert, and this will give an accuracy. Okay, so now this is even more modular than the earlier version. Okay, so let's save this, run this. Now this should be a key n dot key dot print accuracy. This will come, this will come. Okay, let me save this. Test prediction is going, test level is going, and accuracy. Okay, so let's run this. Okay, so it has executed and it has given the same results as expected. So great. Okay, so now for the code purpose, storage of the coding purpose, we will make a 3 versions. So KNN01, this can be taken as a 02, this can be saved as a 02, save, and what is about this code takes the data from CSV file and calls knn classifier and measures accuracy. Okay, save this. Now this same kind of comment we can add for the first version, which is this one. So here it takes a data from within and calls knn classifier and measures accuracy. Okay, so this way if we run this one, then this function we can run, and knn utils is a common. Okay, but in a knn I think this data is going to come here to see. Okay, so let's see if this executes scalar index. So there is a problem. knn classes, knn class prediction. Okay, let's see if this gives a problem. Okay, this doesn't give, and this gives a problem. So I think knn classifier, if we put this in a debugger, so problem comes here. Let us go inside this function. Okay, so what is happening? What was the error here? And line 18. Okay, so here it is. Now if we take this, what is the sort index? So sort index is this. Okay, so it has given the error now. Type error. Only integer scalar arrays can be converted to a scalar index. So sort ints. What is the sort is 1, 3, 5. Yeah, so array is int of 64. Only integer scalars array can be converted to a scalar index. So why this is of int 64? Okay, we can do the casting. Okay, so while using a first version where the data is from the file within, that means the 4 variables we are declaring that time, while calling this test prediction the KNN class prediction function from the KNN utils, just add that, make sure that trend labels are the NP array, because if we give a simple list, then accessing the simple list via these indices will not be possible, and that's why that slight change is required when we are using a version first, where the data is declared and declared within that same file. Let's see if this works fine. Okay, so this is also work fine. So we have now two versions. Okay, so now we'll make one more version, that's a third version. So let me save this file. So in this version we are going to use a standard machine learning library, which is nothing but the scikit-learn, and that provides us so many different machine learning algorithms. And since we are using a KNN classifier, that KNN classifier is also included in this library, that is scikit-learn. So that's turn files, so save. Now why do we use the standard Python library which is used for the machine learning? The advantage of using this kind of library is the function provided by these libraries are used by so many people. It has been tested in a different platforms, and also the library owners takes care of updating as and when there are some modifications, or there are some modifications required to run efficiently on particular platform, so they takes care of that. So now we have a third version. Again we will be having the data in a similar way. Before writing something on the scikit-learn, let's test if sklearn is available or not. If it is already installed, then it won't give a model not found error. So meanwhile we can write we can import this library. So we have sklearn and then neighbors, and then import kneighbor classifier from that. Okay, so what we are going to do, we will have to use this library, we will be changing this function only. Okay, and maybe we will have to give a training data to that classifier object that we might give in between this. So it's somewhat slow, and that's why. Okay, so it hasn't given any error. That means the scikit-learn library is already installed in this in this environment. So let me use this scikit-learn KNN classifier. Okay, so we have already imported data, and here we have initialized the KNN neighbor classifier with the 3. KNN is equal to 3 with the nearest neighbors is equal to 3. Once KNN classifier object is created, now it has been trained, or it has been fitted by using a train data and train labels. So that fitting is done. However, KNN classifier is a very lazy classifier and it doesn't do any fitting, maybe because this is the standard library, so it will do some normalizations and all the range change if there are the difference in the range changes. So we will see that in a advanced machine learning, but for time being, let's use this KNN classifier to do the fitting, so that all the train labels and train data will be given or will be stored in the KNN classifier object. Now once we have already trained, now we can do KNN classifier predict. That's a function, that's a method, and mostly this will take this predict function will take a samples in a batch for predicting. So let's have a array around it, and now it will return here. So why it's giving it a test prediction dot append a KNN classifier and then predict test FV, this one, what is it calling, this one. Okay, so let's say this test prediction append KNN classifier predict. Okay, and then it will give. Okay, so let's run this. Takes a bit of time. So it has executed and we still got the same results, so that means our program is working. And this time in this third version we have used a standard Python library for the KNN classifier machine learning algorithm. So that's it for this video. Thank you.